what we're introducing tomorrow, officially tomorrow, or today for this matter, is a new family of ISRs, new family of integrated services routers, the ISR 4000 series. Now, some of you guys might have been around long enough to remember the old Cisco ISRs, 4500s, 4700s. We tried really, really hard to name these the 4700 series. That name's actually reserved for some UC folks, so we couldn't get that name. But we've got the 4000 series, we've got the 4400 series, and the 4300 series. And if you pay attention and you remember some of those, there's some inside jokes and some nods to the old 4000.
Some of us remember the old 4000s.
Yeah, I used to work on them. And so we did name some of our modules after the old platforms. There were a lot of things that are kind of nods back to the old Cisco 4000s in there. Now, there are 5 members in this portfolio. By the way, if you guys have any questions, please speak up. I heard you guys weren't shy. But as we go, if there's anything that you're curious about, definitely let me know. So 5 platforms in the family here. And the really cool thing about this is that only 4 of them are new. The last guy here, the 4451, we actually launched about 18 months ago. So if you go to Google right now and do a search for Cisco 4451, you'll see a ton of stuff. You'll see a bunch of videos. You'll see performance reports, white papers, lots of stuff out there. Because basically what we had, the situation that we had a couple of years ago between the Cisco ISR branch platform and the Cisco ASR 1000, our flagship head-end platform, WAN aggregation platform, was that there's a pretty big gap between those 2 products, those 2 families, in terms of performance and price and technology and capabilities. But the reality was, I said earlier that a branch is kind of a nebulous term. Well, the reality was that at very, very large branches, folks were putting in ASR 1000s in large branch offices, and that really small aggregation sites, they were putting in ISRs. So there was a lot of crossover in terms of the way people were actually deploying these, but in terms of pricing and performance, there was a pretty big gap there. So we realized we needed a box to kind of pull the 2 families together. We're all internally organized as one group inside of Cisco, so the ASR 1000, the cloud services router, our virtual router, and the ISRs, we're all one engineering team, one marketing team, we're all one family. And so we basically looked at that saying, look, we need a high-end branch platform, we need a high-end ISR. We could either take the ISR G2s, the current generation, and move that up into that area to close the performance gap with the ASR 1000, or we could move the ASR 1000 technology down into that space and make a lower cost ISR basically, or ASR basically in that footprint. And that's basically what we did. We basically brought the ASR 1000 technology down into the branch place, into the branch space at a lower price point, lower performance point than the ASR 1000s, and that was basically the 4451. Now, behind the scenes, what it actually let us do is it allowed us to get a head start on building all of the interface modules, all of the technologies, all of the software features, because we were moving from iOS, classic iOS, it's been around for 20 years, to iOS XE, which has been around for about 5 to 7 years, that runs on the ASR 1000s. We were moving from one software architecture to the next, so we wanted to make sure that we had plenty of headroom, plenty of leeway to get all of the software features that we needed completely finished, to get all of the interface modules that we needed to out the door, and just to make sure, honestly, that we didn't get anything wrong, that we actually got the box out there, it was out for a year, and then we can come out with tomorrow and introduce the rest of the portfolio. So we're really only introducing 4 new products tomorrow, but in reality, we're introducing the entire family. The 4451 was really just a teaser for the rest of the family. Okay? So how familiar are you guys with ISRs currently, with the current patch of ISR G2s? So the 1900s, 2900s, 3900s, you guys are familiar with where they fit and what they look like. Okay, sounds good. So currently today we have about 11 ISR G2s that fit the entire modular ISR portfolio. Now the 800 series we don't necessarily qualify as this. They're what we call our fixed platform ISRs because they are fixed configuration. They're basically what you order when you place the order for the system is what you get. There's no interface modules to change out the WAN interfaces or anything on that. But for the ISR G2 modular platforms, we have about 11 routers in there that fill the entire portfolio there. Now what customers have told us is that it's really, really great. You give us an option to meet any possible performance and price combination or need for modules and interfaces and slots that we have in our network, but at the same time it's really, really bad because you give us a choice of 11 different platforms to choose from to meet all of these different needs. So one of the things we tried to do with this family is that we're giving you 5 physical platforms, but in reality, we're giving you 10 different performance levels. So each one of these boxes is a multi-core platform, multi-core architecture. We use a multi-core data plane very similar to the ISR 1000, if you're familiar with that. And what we're basically doing is we're using a portion of those data plane cores at the entry-level performance level, and then we're basically turning on all of the data plane cores for the fully licensed performance license level. And it varies on platform, how many cores are used and that kind of thing. So that's why you see a performance range here. The 4451, been out for a while, it goes from 1 gigabits per second to 2 gigabits per second. And now these are all total system performance numbers with services configured, with services enabled. We call it an ASIC-like performance level. I'll talk a little bit more about that when we get into the architecture. But you get a very, very flat, predictable performance level out of these boxes, regardless of whether you're doing just basic IP forwarding, plain IP forwarding, or you turn on NAT, you turn on QoS, you turn on IPsec. You're still going to get that 1 gig to 2 gig performance level across the majority of configurations. 4451, you get into that at an entry level with 1 gig of total system forwarding through the box, and with just a CLI, with just a license configuration, it really is literally just a CLI, you can double that performance to 2 gigs. And that's true for the rest of these platforms as well.
So what you're saying is you're going to ship me, say, a 4351, and it's going to have, I don't know, 4 cores. And by default, with the base image that comes on the router, you're going to turn off 2 of those cores.
Basically,
to hit a specific performance profile that's a specific cost for the customer.
Yeah.
And the license key that unlocks the other 2 cores is separate from the existing licensing bundles of what, data security, voice?
Yeah, essentially, yeah. Essentially, it's a separate license, but it's the same image, it's the same.
So what happens if I run into a situation where, this has happened at a VAR I used to work with. So I ordered this unit, and it came with a base license, but I needed to add a voice license to it. Does the voice license, does it unlock any additional cores for things like, DSP, utilization, or anything like that? Or this is a completely different set of licenses?
This is a completely separate, it really runs parallel to all of those standard technology feature licenses. And that is different from some platforms. Some platforms do have a license that will unlock DSPs or unlock physical interfaces. On the ISRs, on the 4Ks, if you have a performance license, it just turns on those additional data plane cores, and they give you better performance for pretty much everything, other than where you have a specific hardware resource like a DSP.
Is this a customer feedback thing? Did they say we actually want to pay a little less for a router even if it doesn't run as fast?
It's a little bit of that. It's a little bit of basically our customers telling us that I've touched my branch routers every 5 years at best. A lot of times it's 7 years, more than that. And so they say basically, I'm seeing Ethernet WAN everywhere. I can go to my service provider and say, look, I've got a subrated 1 gig connection or a subrated fast Ethernet connection today. I can call up my service provider and they'll just change the shape rate. And now I have a 100 meg connection or a 500 meg connection or a 1 gig connection. And so they're basically saying, look, I still don't want to touch the router when I do that. So it makes a lot of sense if I can buy a platform and only pay for 100 megs of performance today, and then when the branch grows, when I have the needs from it, I can just turn a key and basically double the performance.
Can you do me a favor and make absolutely certain that when you publish all this information, you do it in very short declarative sentences, maybe highlight the text in a certain way, because this really sounds a whole lot like the ASA 5505, where it's like, here's the entry-level model that can do like 20 users, and you can only have so many MAC addresses that go through it. But if you really want to do all the cool stuff that we tell you that an ASA can do, you have to buy this other key, and that unlocks everything.
Yeah.
So I think communication is going to be clear for this.
Okay.
And that was actually the platform I was referring to when I said that at least on our side, on the ASR and the ISR side, we are purely just turning on and off data plane cores.
Okay.
So all functionality is there, all memory is there, all DSP resources are available. So you turn on the performance license, you basically just get more data plane cores. You get more of pretty much everything except for hardware resources. Like you don't get more DSPs magically, because we're not licensing that. At least not on the ISR 4000s. It's not something that's there, but really disabled. And by the way, we have evaluation licenses for everything. So if you get into a situation where you want to, if you're running up against that wall and you say, oh, I just need a performance license, you can turn that on for 60 days. And then beyond that, everything is right to use. So if you turn it on and then after that 60-day evaluation period, it just magically converts to what we call a right to use licenses, which is basically a trust license. The one exception to that is strong encryption. Government requirements for that, but other than that.
I think, honestly, to bring up your point, I think this pricing will speak strongly. I mean, obviously, it's out of scope what we're talking about today, but the pricing of this will speak strongly to where this is adapted. And as long as it comes in strong, I think it'll end up being good.
What we've basically done at a high level with pricing, and the same thing we did throughout the ISRs generally, is we always try to keep pricing on par with the previous generation. So these boxes are the same prices as the ISR G2, 4 to 10 times faster depending on where you are in the portfolio and what you're looking at. But you're going to pay about the same price. So a 3945 at a 350 megs with services, you're going to pay about the same price as a 1 gig 4451. So we try to keep pricing on par, but give you a heck of a lot more in the box. And that being said, the performance curves on these things change dramatically. If you look at them, and I've got a slide that shows a little bit of that, where you go from a traditional software-only router running on a single CPU core, traditional ISRs. Every feature you add, every little bit of configuration takes your performance down by just a little bit. Some features a lot. And on these platforms, on the ASR 1000, what you see is a very, very flat performance curve, and then eventually you've got just enough work going on that it tapers off slowly. And I'll show you some stuff that we've got on that as well.
So how is that? Like, how is it achieving the magic of not degrading?
So two different things that we're doing here. One is, of course, the data plane core. Basically, it's a completely separate control and data plane architecture, multi-core architecture in the data plane. So that, through the parallelism of the data plane, is on its own giving you a very shallow performance curve. The other thing that we're actually doing is we actually have a shaper inside of the system itself that actually limits you to 1 gig and 2 gigs of performance. And that was another customer feedback, basically, is that I don't want to guess about what my box is going to do when I put it into my environment, when I put it into my network. I want to know very clearly, very specifically what this box is going to do. It's either going to do 1 gig, 2 gig, 100 megs, 300 megs, whatever. So we basically have a shaper under the hood that basically cuts you off when you get to that 1 gig or that 2 gig limit. And so basically you're buying a 2 gig platform just like it's an ASIC that only does 2 gigs of forwarding, but it does that across a huge variety of features.
So if you're running sorry.
Yeah, so what you're saying is you can actually do 2 gig of pretty complex forwarding. Yeah. But if I only do IP forwarding, you rate limit me to 2 gig anyway.
Still get 2 gig. But
I could get 10, but you rate limit me.
And this was actually, to be totally honest with you, this was a long discussion we had internally with these platforms, because basically what we're doing is we're handicapping ourselves in magazine tests. Because in a lab test, if you're just doing IP forwarding versus IP forwarding, you're going to get 2 gigs, or whatever the license performance is in the box. In the real world, no one does just IP forwarding. It's going to give you 2 gigs in the same environment. The reality is, in that lab test, you would be doing 2 gigs, and you might see 10%, 15% data plane utilization. In the real world, where you're doing a whole slew of features, you might see 2 gigs with 50% or 30% data plane utilization. So, it was a long discussion that we had, that we erred on the side of predictable, solid performance rather than a guessing game of trying to decide, which platform is going to give me the right performance in this scenario with this given configuration that I have. And that's something that on the ISRs and on a lot of platforms, we have to play the game a lot of times on most days is, we don't have a specific performance test with this exact configuration from a customer. And it's becoming even more difficult now with all the application visibility that's going on within the network, because not only is the configuration going to change your performance level, but the actual application traffic going through can have a great effect on the performance. And so that's why we went down this path to say, basically, we're building in lots of excess capacity into these boxes so that we can hit that 2 gig level or that 1 gig level across a pretty broad set of real world deployments. It's a great feature in real customer environments, in real network environments. In magazine tests, honestly, it means that we're not putting our best foot forward, but that's okay. Because while we would love to show off great, in a head-to-head lab test, we'd much rather, have something that's solid and predictable in a real configuration.
And the second question is, why didn't you go for a wider range of performance figures? For example, why didn't you go from 100 meg to 1 gig?
To be perfectly honest with you, if we had our druthers, we would have built probably 3 platforms: one RU, one 2RU, and one desktop form factor. That's just not financially possible. We would love to have done that. It would have made our job a lot easier, and it certainly would have made the customer's job a lot easier. It's just, I mean, honestly, to build a platform that does 2 gigs, we have to put so much into that platform that we can't sell it at 50 megs. It would have been really nice to be able to do that. We also looked at different levels of granularity in terms of licensing, in terms of doing a license every 100 megs, every 50 megs, and that's just, we tried to hit a balance of just 2 license levels per platform. It's enough that you can wrap your head around, but still flexible enough that it gives you 2 real distinct performance levels on each platform.
By the way, when you mentioned that after 60 days the license becomes sort of trust-based, right, to use.
Yeah.
Obviously, I have to pay for that eventually, but can I pay a bit later and start at a certain previous date? Because sometimes I don't have the budget to do it.
That gets into Cisco One licensing, and that depends on your specific relationship with the Cisco One licensing folks. Technically and legally, no, I have to say that, but in reality, yes, the box is not going to, we sort of aired, at least on the ISRs, at least on our platforms, that we're going to do no harm to your network if we can help it. And so that means that basically if you turn on the performance license, if you turn on security, you turn on data, you turn on app experience, it'll keep working forever. Now, it will turn on a syslog message when you get up to that 60-day limit, and it will say, hey, you might want to pay for this. If you're running the Cisco One licensing manager, it will show up flags that say, hey, look, you're using more of this license than what you have actually purchased, and hey, you might want to go buy some licenses. But it's not going to shut off your network. So there is certainly some flexibility inside of the network itself.
In terms of pricing for a license, do you have a ballpark in terms of so for that performance license, like what percentage of the cost of the original platform it's likely to be? Since we're doubling performance, right?
It's not a doubling of the performance, and Jay can keep me honest here. But for example, the 4451, I believe it's an extra couple $1,000s for the license that doubles performance, and it varies on each platform. So if you're going from a 50 meg to a 100 meg box, that's a much less expensive license than, and as a fraction of the portion of the base price, it's still I don't know, what would you say?
It's like 1,000, 1,500, 2,000, that's closer.
Yeah.
It's not a doubling of the price of the system, certainly not.
Very good.
Yeah. And full disclaimer, I'm a technical marketing engineer, so I have zero knowledge when it comes to pricing. So I would love to answer your question, but I just don't know. I just happen to know that one's 2,000 off the top of my head.
So, if you're running a policer under the hood, that's limiting us to the whatever we're licensed for. Yeah, sorry. Yeah.
That's fine.
Why cut off cores then?
Because what we want to do is make sure that regardless of what your configuration is, if you are at a base 1 gig license here, and you're running a very feature-rich configuration so that you're below that 1 gig level. Like you could turn on AVC, NetFlow V9, you could flow on a lot of stuff. That is eventually going to take you below that 1 gig level. If you buy that performance license, you will always, in 100% of the cases, see a performance improvement. Even if you're at, say, 800 megs, you will see, on this particular platform, you'd see roughly a doubling in performance, other than maybe some features that are memory locked and stuff. But you will always see, 100% of the time, a performance improvement by buying that performance license. So that's why we turn off cores. Just because we don't want to get into a situation where we already have all of the cores on, but there's a shaper in place, but you bought that performance license, sorry, it's really not going to do anything for you. So we want you to always see a performance benefit there.
Or it may not do what you expect, right?
Or it may not. You would expect anytime you put more money into on a performance license, you're going to get better performance, and that's why we do it.
Right.
Yeah, and that's honestly one of the ways that we came up with these numbers, and you'll see that it's a doubling on everything except for the 4331, and a lot of that is just because that's where the math worked out with the number of core counts. It was very straightforward on a 4331 to do about a 100 meg limit and about a 300 meg limit, just with the way that the number of cores worked out.
Let's see a little more about this thing now that we get the licensing stuff sorted out.
Yeah, absolutely.
Like I said, I am perfectly happy if we get through, no slides if we just talk about the technical insides and outs of these boxes. High level information about the overall family. So there's 2 real families here, the 4300s, 4400s. Biggest difference there for you guys and for most customers, dual power supplies on the 4400s, no dual power supplies on the 4300s. That's really the biggest difference. There's also some internal architecture differences we can talk about on the architecture slides, but the real thing is dual power supplies, no dual power supplies. What you actually see here is a 4431 there, and that's a 4331. Now the 43s and the 44s, that's pretty straightforward. The third number there, just simply the number of slots in the router. 4331 has 3 network interface module slots. 4331, 4331 has 3 slots, 2 NIMs, and 1 SM. So, you've got a variety of options there. We also tried to give you some flexibility in terms of rack units so that you don't have to go all the way up to the highest end platform the way that you do today on an ISR G2. If you're doing something like analog voice aggregation, PRI, T1 aggregation, something like that, you need a lot of interfaces. You need Ethernet switch ports, something like that. You can hit a 4351 that gives you some pretty good flexibility in terms of interface density without having to go all the way up to a 1 gig or 2 gig platform. Similarly, if you just need Ethernet in, Ethernet out with services, you can really do a 4431 there in a nice 1RU form factor without having to buy a 3RU router, and you're only using 2 interfaces. So, that's why you see some real changes in the portfolio there. Okay. We did this slide just for fun. A couple of us sitting around in the office that have been around for way too long. Just basically drawing a straight line back to where we originally came from. And if you look at some of the...
IGS.
There's some things that we left off. You know what's funny? I actually do have an IGS in the lab. I actually do still have an IGS somewhere. I did have an AGS, but I actually gave it up to one of the Cisco museums that we built in Bedfont Links over in the UK. But there are some products here that aren't covered. But we have a very, very straight line pedigree all the way back to the 2500 series. That was our first platform that was designed specifically for a branch environment. It was a fixed platform, where we started thinking about, integrating services. Really was on the 2600 where we introduced firewall modularity onto the system. The G1s and of course the G2s, we took that even further with integrated compute. The UCSE series, where you now have full server blades inside of the routers, and then finally the 4400s and 4300s, where you have full multi-core architecture, split control plane, data plane architectures in the high end of the portfolio. Okay, so big things that really set this guy apart, this family apart. Of course, services-aware data plane. We've built these platforms from the ground up, really thinking about that whole intelligent WAN I talked about earlier. So everything that we did when we built these platforms was really designed with application awareness, with layer 7 forwarding. Really, so we're really much more than a traditional router anymore. As a matter of fact, in a lot of our literature now, we've tried to remind ourselves not to call these things routers as much as possible because they do so much more than just simple layer 3 or layer 4 forwarding of packets. So you get a lot of stuff in there. Virtualized services framework, we run a Linux kernel, a Linux image inside of our control plane, which means that we can do virtual machines inside of the box. We can do standard Linux containers, KVM and LXC, Linux virtual containers and kernel virtual machines inside of the router itself with no additional hardware. So you don't need a module, you don't need anything really additional to support that. We've got an internal capability for hosting services.
That actually brings up an interesting question. The Cat 4500 running iOS XE on a dual-core processor can actually use the other core to do things like inline Wireshark. Can you do that with this box?
Technically, yes, although we haven't productized Wireshark on this. The Cat 4000s, and I don't know if you guys are aware of this, run iOS XE. So does the ASR 1000 and the ISR 4000s now. They're pretty much aliens to one another. They are different iOS XEs, basically. We are going through a path internally to converge all of our iOS XE platforms onto a single image. I could tell you.
From some other vendor.
I could. Well, I mean, they are probably 95% similar, and it literally there was no real fault for why it came about. It's just sort of development cycles were where they were, and long story short, we're going through the work right now to converge everyone onto the same platform. What they use for Wireshark internally is exactly the same architecture as what we use. It was actually an architecture that was developed for the ASR 1000 originally. They just don't disclose it, very clearly as being KVM, LXC, and virtual containers. But what they're using for Wireshark is exactly the same thing. And there's no real technical reason why we couldn't do that on the ISR 4000s. It's just not something we've really productized yet. That's certainly potentially there.
So you have the capability to do KVM or containers.
No, we're doing it.
No, but can I use it? Can I put my stuff into a container?
Not today. So what we're doing is So we're proceeding down this path, but we're doing it very cautiously. So technically, yes, absolutely. But realistically, what we're doing is we're saying, oh, look, we've got inside of the ISRs, we've got the UCSE series, which is a full-blown server with lights-out management, out-of-band management. You can support VMware, Hyper-V, full-blown hypervisors. And that is a separate CPU, separate drive, separate memory from the core system itself. So whatever you want to do there, perfectly fine. And it has absolutely zero chance of affecting the rest of the system. Now, when you run a KVM or LXC container, theoretically, it's a very secure, very protected environment, but it is still using the same memory. It is still using some CPU cores that are shared with the rest of the system. So we're being very cautious with that. So today, all we're supporting is Cisco containers. We're in the process right now of working with third parties and saying, okay, what third parties are interested in here, and we're going to be very careful to make sure that we've got the development tools that they need. And then we just kick the tires to make sure everything's stable. And then we would expect over time to open that up more and more.
That sounds like AXP, and we all know how that ended.
Well, AXP had some very tight handcuffs on it. And that was the failings of AXP, was the very, very tight handcuffs. What we're doing right now is more of a development of the underlying technology, because the only real thing that we have in these platforms that is special as far as KVM and LXC goes is a digital signature check, just to check to make sure that whatever this OVA file is has been digitally signed and is approved to run on this system. So that means that we can, over time, just open that up to third parties and give them their own signature. We can, over time, open that up even more. And we don't have to do the very, very tight handcuffs that AXP had. Because you're absolutely right, we were the same group that was around then. We don't want to go down the AXP path. That's something I can say without a doubt, is that we don't want to be involved in looking at every single application and signing that off.
No App Store then?
We really want to. I really want to. But no App Store, yes.
No App Store.
Now that you mentioned the UCS blade, why wouldn't I just turn this around and buy a UCS C-Series server and put CSR as one of them?
That's certainly an option, and we've got folks looking at doing that. The difference really comes down to hardware in a lot of cases and in terms of support cost. So, if you look at your traditional server, even UCSE server, they're typically designed on a 3-year refresh, time window. Server technology, drives, CPUs just generally evolve much, much faster. So you're looking at, upgrading your servers every 3 to 5 years. Networking technology, especially in branch environments, we don't expect folks to upgrade more than 5 to 7 years. And we design these platforms to be deployed for 10 to 12 years. So that means that the fans that we choose, that means that the drives and the whole system itself is designed to be out there for 10 to 12 years, that the core system itself is going to be rock solid and stable for that long time frame. And it is a choice. I mean, there are still some people that are perfectly happy taking a look at their branch office every 3 years, and they are looking at putting UCSs in the branch and running CSRs there. The reality is that the support cost and the maintenance cost to that explodes pretty quickly when you look at support costs for servers and different hardware and software on top of it. That being said, we are perfectly happy with both models. The CSR is our group. Under the hood, it's all one iOS XE architecture. Technically, the difference between an ASR 1000, an ISR 4000, and a CSR is only in the data plane implementation. Software is exactly the same. The under the hood features exactly the same. The engineers and developers are exactly the same. So if we can tell you to run a CSR on a virtual router in your branch, we're perfectly happy to do so. And I think over time, we're going to see more folks interested in that at least. It's just something that for right now, really having the hardened router that can be out there for 7 years, for 10 years, and having that virtualization capability either on the router itself or on a blade in the router gives you that flexibility, but it still gives you that base platform that can still be there for 5 years, 7 years down the road.
So short summary, this box will survive a decade, and good luck with the server.
Maybe with the server?
Good luck with the server.
And, well, in some cases, but I mean, honestly, you just don't typically see servers deployed for that length of time. And I mean, we design routers to go into a much broader temperature range, to much different environments. So it's a little bit of apples and oranges, but there are certainly folks out there that are perfectly happy in their environment, that maybe they have IT staff on site. They're perfectly happy with running a server with a virtual router on it. Yeah. We'll sell you either one perfectly happily. Yeah. And I think I pretty much covered a lot of the stuff here. Certainly Converged Branch with UCSE series. I mean, that's a huge selling point for us. We're seeing a ton of interest on the UCSE series. As a matter of fact, there's one in that guy right there. And pay as you grow, that's true really across the board, not just with performance on demand, but with the ability to add services to the virtual containers, to add capabilities to the virtual machines, to add configurations and packages and licenses and everything, as you go down the road, basically.